Hi, I'm Mr. Huber, and in this video we're going to talk about exercise 2e. Well, f of x is equal to x squared minus 5x plus 6. Rewrite each function in vertex form and sketch the graph. And from time to time I'm going to work out the zeros, although the exercise doesn't ask for it. Now look, well, we need to complete the square. How do we do this? Well, let's think about this. X minus k squared is x squared minus 2kx plus k squared. So we can see that this is always twice the value of this, or twice the variable back here. So what we do in order to complete the square is x squared minus 5x plus 5 halves minus 5 halves plus 6. So by doing nothing in an intelligent way, we can complete the square. So I'm adding what I would want to have back here, which is half of this squared. Look, you have 2k here, and back here you have k squared. So half of this squared. So now this will be a perfect square, and we will be able to rewrite it as x minus 5 halves squared minus 25 quarters plus the 6. The 6 is going to be 24 quarters, because we need to add these two up. So we will get x minus 5 halves squared minus a quarter. So now the vertex is obviously 5 halves minus a quarter. We also know what the y-intercept is going to be. The y-intercept is 0, 6. Because when our quadratic is in general form, then this back here is in fact just the y-intercept, or the y value of the y-intercept. And the point where the function, the graph, intersects the y-axis is at 0, 6. So now we can do a qualitative sketch. I'm not going to draw it in an accurate way, just a qualitative sketch. Well, we know that it's going to go through 6, so let's just say this is 6. Let's say this is 5 halves here somewhere, just 5 halves. And then let's say this is a quarter, minus a quarter, sorry. So this will be the vertex. Now, let's draw the graph. Clearly, this is not an accurate drawing. But well, it gives us a good idea about how the graph looks. Now, what you could do, if you wanted, you could work out the zeros. So let's do this in this case. Well, the zeros is, in fact, the answer to this question. For which x is f of x equal to 0? So we said we're going to set this equal to 0. Minus a quarter is 0. First, we're going to add a quarter on both sides. Now we're going to take the square root, and then it's x minus 5 halves plus equal to plus minus a half. Okay, why is that plus minus? Well, you know, x squared is equal to 16, so x is plus minus the square root of 16. X is plus minus 4, because 4 squared is 16 and minus 4 squared is 16. So whenever you have to answer or to find the solutions to an equation like this, you know that you have two possibilities, two solutions. Well, in this case, the solution set would be minus 4 and plus 4. And in many cases, you just write plus minus 4. Okay, so this is the idea behind it. That's why we have to write a plus minus. Well, the square root of a quarter is a half, because a half times a half is a quarter. So the plus minus because it's an equation. Now, x is 5 halves. We're going to add 5 halves on both sides, plus minus a half. Now we're going to get the zeros. Well, 5 halves plus 1 half, that's 3. 5 halves minus 1 half, that's 2. So apparently, the zeros are here at 2 and 3. So we have quite a few pieces of information. We know quite a few important points of this graph, and that helps us to understand the graph quite well. So I hope it wasn't too difficult. See you in the next one.